talked about a little bit so far, and it's going to be increasingly more sort of the main focus over the next few days, is this process of succession. So yeah, it's the evolutionary process of any given system. In this context, obviously, we're focused primarily on ecological systems, so looking at land systems and how they evolve over time. And at the base of that is just observing that process on its own, and then as we move through the design process, we'll look at how we can kind of guide succession and where our actions and what we do can have a beneficial impact on the direction of that energy that's always happening. So like in a situation like this, we're in a really nice spot because we're on the edge of these two ecosystems. There's this grassland here and then this somewhat mature forest over here. I think a really useful exercise is to just kind of think about all of the past activities that kind of brought these systems into what they are now, and what energy, what actions, maybe human actions or animal actions sort of brought these systems into their current state. And if we ponder that for a little bit, we can probably come up with a lot of ideas as to how things became the way they are. The first thing that I look at is this stone wall here, which is obviously a remnant of some kind of human activity. So I'm imagining this was probably all forested at one time too, and it was cleared. Yeah. The stones were moved. So what would happen if Ben or whoever's using this land were just to leave and let it go? Where would we see this succession go? The edge is very abrupt, and that's all because of the management strategies over the past 50 to 100 years. But if we were to go into an area where there's like a natural grassland that meets up with the forest, there's always this transitionary edge where we see this structural diversity that kind of cascades down. And those places are often, like we were talking about yesterday or the day before, those are some of the most diverse habitats, those edge places. I think something that we can pay attention to as we move around and look at the property is always looking at those edges, and that's kind of why we're where we are, so we can sort of focus on this. And that's the whole idea, is that we can really take a lot of these patterns and utilize them in our own landscapes. So can anybody identify any of the species growing on this edge here? Maple. Anybody know what this is?
No idea.
This is Amelanchier, serviceberry. And that's a great example of one of those species that can really occupy that edge ecosystem. And it's a great wildlife plant and also a fantastic food that's edible for humans. Yeah, very good berries. There's organisms that are coming into a place, and these quote-unquote pioneer species are, their purpose is only short-lived, and they're there to create conditions for other species. And that's an ongoing process, and it's not, a lot of times when we learn ecology, it's taught in a linear fashion. So we go from a grassland and then ultimately to a mature climax forest is what we refer to it as. But when we actually go out and look at these systems, we learn that it's much more dynamic and sort of splotchy than just this linear path. And there's always these disturbances. So maybe we do have a forest that's growing up and we're starting to get things like sugar maple and things coming in. But then, something happens, any kind of disturbance, maybe a tree gets, hit by lightning and falls down. So then we've basically backtracked succession just in this given space. There's more light there. New organisms can come in and take home. It's a dynamic process, and it's always cycling and changing in different areas. As we continue on, we'll learn, again, how we can sort of intervene and have designed disturbances that work to our advantage. I like to say guide succession, sort of as stewards of the land. But it can sound, I guess, sort of selfish too, and that's not the idea. Again, this whole thing with permaculture is we're trying to create a system that's beneficial for all organisms, not just ourselves. In observing a given space and thinking about, what's happened here and what the future might look like, and one of the really important parts is to try and observe it in kind of a non-biased way. So we can, like for me, it's so easy for me to walk along this edge and think, oh, this is great, let's plant some pawpaws here. But that's not the point. The point is, okay, here's this edge, it's semi-shade, the sun patterns are kind of dappled based on the canopy here. There's going to be a little bit of more moisture here than there will be 10 feet out because we're on the edge of the forest. So what are those conditions conducive to? And that's where, the assessment part comes in, the so what. Yesterday we briefly touched on processes and features. A lot of times features influence processes. In a space like this, even just the most basic thing like this forest edge, it's going to moderate throughout the day the temperatures in this area and how fast the dew burns off and things like that, which are all processes of this space, but they're all directed by, the canopy here, the soil types, all of these features. So it's the two are kind of interworking with one another. So the tree canopy would be the feature, and the casting of the shade would be the process. And that changes throughout the day too, based on the sun angles and all these things. So if slope's a feature, what is a process that might influence?
Well, surface water flow would be one, or erosion.
Right.
Airflow.
Airflow, yeah, exactly. One of the things I look at is like the slope of the forest kind of sloping towards us, and this wall here, thinking about what that might do over time. Does anybody have any ideas, like aside from maybe airflow and things like that, any other functions or processes that this stone wall is influencing?
Well, it's a bit of an impediment to flow, so you're going to get a buildup.
Exactly, yeah. Buildup of
Moisture.
Nutrients, debris, organic matter,
right,
air.
all of those things. So yesterday when we went over all of the different topics on the scale of permanence, when we're out here, and I'm going to leave you guys pretty soon to take notes and do things on your own, those are all of the areas we want to think about. In regards to features and processes, we're looking at things like water and soil and vegetation and wildlife, so animal corridors, species composition, what trees are growing here, what kind of herbs are growing in the understory, access ways, and then thinking about, like I sort of framed it at the beginning, the past of this space, the history of this space, and then also what potential future scenarios might arise, whether it's without any human interaction, just thinking about that, in the most basic form, and then also what could happen with our intelligent, sort of guided disturbances. So I'm going to ask you guys to just spend the next 20, 30 minutes in this space, just like maybe not far out in the field, just kind of on this edge habitat here, and take as much notes as you can get. Just jot stuff down about what you see in regards to all of those topics on the scale of permanence. And then basically what we're going to do is take that stuff back and just synthesize it into a very quick map and see what you can come up with. In our role as designers and observers is, like I think we mentioned it once before, is we're like ecological detectives, trying to kind of paint a picture of what once was and where it's going and how we can be involved in that.